Hello everyone. Today let's solve the problem number 141, linked list cycle. Right. So what the question states here, we are given head of the linked list. You can clearly see here. Let's come to the example part here. We are given an head of the linked list here. We have to determine if there is a cycle in it. So we have been given head of the linked list and we need to determine if there is cycle in it. A cycle exists if node can be revisited by continuously following the next pointer. So just keep this in mind. I'm stressing this one. This is very important, right? So a cycle exists if any node can be revisited by continuously visiting the or continuously following the next pointer. So this is very important. So we have to return true if a cycle is present. If the cycle is present in the head, then we have to return true in that case. Otherwise, we have to return false. Otherwise, what we need to do, we have to return false, right? So if the cycle exists, then we have to return true in that case. If the cycle doesn't exist, then we have to return false in that case, right? So let's come to the first part here, first example. Here you can clearly see, first thing is, whenever you saw this one, linked list cycle, if we need to detect the linked list cycle, right, you would have already guessed that we'll be making use of tortoise and hare algorithm, or you can just call that one as Floyd's this one cycle detection algorithm as well, right? So yes, we'll be going with the tortoise and hare algorithm. For now, let's discuss the first example here that they have given. So head, here we have been given 3 to 04 elements, right? 3 to 04 elements here. So here they have said here, there is a cycle in the linked list where the tail connects to the first node. Where the tail, this one, connects to the first node, right? So this is zero index they have said. So this is zero index they have said. So cycle exists. So here in this case, we will return true. So we will be returning true in this case because here cycle exists right here in this case, right? So cycle exists here in case of this one where the tail connects to the first node here. So what we will be doing, just hint here. So we will be discussing the same thing in the approach. So we will be going with the tortoise and hare algorithm, right? So we'll be considering 2 pointers. One pointer which moves one step at a time, and the first pointer which moves one step at a time, and the second pointer will move 2 steps at a time, right? So that's what it will be helpful in detecting this one, what do you call, cycle detection, detecting the cycle within the head of the linked list, right? So here in this case, as cycle, we have detected we have detected the cycle here. In this case, we have returned true. Let's come to the second example here. So just give me a second here. So here in this case, head we have been given 1, 2 and position 0, right? Head 1, 2, position 0. So true here in this case. See, here there is a cycle in the linked list where the tail connects to the 0th node. Here you can clearly see, I have clearly shown here, right? So in this case, we have to return true. Whenever the cycle exists, we have to return true. Else we have to return false. Here we have only single node, and position they have given -1 here in this case. Position they have given 0 here in this case, right? So here in this case, there is a cycle in the linked list where the tail connects to the 0th node. So that is why we have returned true. Here in this case, we have been given position -1. So false. Why? Because there is no cycle in the linked list. We have only single node. Cycle cannot, at any cost, the cycle doesn't exist, right? So for this, at this case, we have to return false, right? I hope the question is completely clear. What we need to do is completely clear as well. So let's completely, let's this one discuss in detail by considering the first example in the approach. You'll understand this one even better, right? So first, let's discuss the approach, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So here, the first thing that we need to note down here is we will be going with the Floyd cycle detection algorithm. I have already said this one, right? So we'll be going with the Floyd cycle detection algorithm or tortoise and hare algorithm, right? So this is fine. So I have considered the first example so that it will be easier to understand. We have already discussed this one, right? We have the element 3 to 04. So position, they have given 1. So here -4, here in this case, this will be cycle. This forms the cycle. Let's see that one itself. So how it forms a cycle? Basically, position 1 they have given, output we have to get here as true. Let's see. So here, let's see the step-by-step execution. So here, first thing is we are initializing the 2 pointers. Means we have to initialize 2 pointers. We'll be making use of the 2 pointers. One is slow and another one is fast. Slow moves 1 step at a time, as I've said earlier, and fast moves 2 steps, right? So I hope this is clear. Slow and fast pointers we're making use of. Slow moves 1 step at a time and fast moves 2 steps, right? So if fast reaches null, then we have to return false. First, at any cost, fast shouldn't reach null, because if fast reaches null, then there is no cycle detected, then we have to return false in that case, right? So just keep this in mind. Let's move on with the third step here. If slow and fast meet at the same node, then a cycle exists. Just keep in mind, just keep this in mind. If slow and the fast meet at the same this thing node, then a cycle exists, right? This we know. That's what we need to find out, that whether a cycle exists or not, right? If slow and fast meets at the same node, a cycle exists, right? In that case, we have to return true. If the cycle exists, then we have to return true in that case. So let's go with the first example. Let's discuss the first example, right? So here we have 3, 2 and 3, 2, 0 and minus 4, I think. Yeah. 3, 2, 0 and minus 4, and position is 1 here in this case, right? So slow, first we have it 3. Initially slow, this one is correct. Slow, fast is at 3. Both the pointers, slow and fast pointers, this one is fast, this one is slow. Initially this is at 3, right? So next step, slow will move here, this one. Slow will move 1 step at a time, it will move to 2, and fast will move 2 steps at a time, fast will move this one here. Slow, this one fast, right? This is fine. This is for the second step, right? So let's move on with the third step here. We will move slow to 0. Means slow here 1 step at a time. This one will be slow. Second, this one third step. Fast will move 2 steps at a time. This will be minus 4 and 3 here. Here it will come, right? 3, right? So yeah, here I forgot. So here what we will do. So we are. So in this case, we have moved slow 1 step, but when we move fast here, 1, 2. So here we cannot move, right? So it will be null here in this case. So what we'll do, we'll consider from first element here. We will consider this one once and twice. So fast will move to the 2. So fast will be 2 here in this case, right? So fast will be 2 here in this case. Next step, slow, we will move slow to the slow 1 step, means from 0 to minus 4. Now slow is at the minus 4 and fast we can move 2 steps right here. Fast is at 2 now, 3 and 4. When we move 2 steps, fast is at minus 4. Now slow and fast both are at minus 4. Slow is also at minus 4 and fast is also at the minus 4. Collision. Now cycle is detected, right? So there is a detection in the cycle. So there is a detection in the cycle, collision happens here, and cycle is detected in this case, right? So if you got confused in the third step here, so when we move 2 steps ahead here, this will be null. We cannot consider this one. So we will start again from here and we will move 2 steps. Means 3, 2. 2 steps here, this will be 2. So fast will be 2. This step. Don't get confused here, right? So this is fine. So this is it for the step by step execution. Now, as we have, as the cycle is detected here, due to the collision, cycle is detected here. So the final output that we need to return here in this case is true, right? So if the cycle is detected, we need to return boolean value true. That's what they have given, that's what they have given in the question, right? So I hope this is completely clear. So the output that we got here is true, which is equivalent to the output that they have given for the question 1, nothing but true. So in this case, the approach works absolutely correct in this case, right? So the approach works absolutely correct in this case. So now we are familiar with the approach, right? So now we are completely familiar with the approach. So as we are familiar with the approach, let's discuss the this one edge cases one by one quickly. So let's come to the first edge case here. So first edge case here is for the empty list. When I say empty list, head equals null I have considered. Empty list right here. Output will be quite obviously false. We don't have any element, right? So we don't have any element in that. So quite obviously the output will be false here in this case. We need to return false. So the second edge case here, in this case, So here simple, no nodes, no cycle, right? No nodes, no cycle here. So that's the reason we need to return false in this case. Let's move on with the second edge case here. In this case, single node, no cycle. When I say single node, no cycle here in this case, only one node we have, so cycle is not possible. We have seen this one in the example itself. Third example, I guess. Position, they have given -1. Output will be quite obviously false, right? So single node, uh, whenever we consider single node, it will not be having any loop. Here in this case, it doesn't have any loop. So single node with no loop, quite obviously the output will be false in this case. Let's move on with the third edge case here. Two nodes cycle exists. When I say two node cycle exists, we have two nodes here, 1 and 2 here in this case. Position, they have given 0. 0 index, this is 0, this is 1. Position, 0, right? Output will be true because here tail links to the head. Tail links to the head, nothing but 0 here in this case, right? So in this case, output we need to return true. If you want to know how we got this output, you can just follow the same steps that I had shown by considering the example. You can just follow the tortoise and hare algorithm. Just apply the tortoise and hare algorithm step by step. You'll detect the cycle will be detected here on this case, right? So there will be collision and you'll detect a cycle, and you we will at that point of time we have to return true. So boolean value true in this case, right? So this is fine. Let's move on with the fourth edge case, long list, no cycle. Here we have 1, 2, 3, 4, 5, 6, and position we have -1. Position we have as -1 in this case, right? In this case, output is false. So I have written 2 here. Sorry, this one is false, right? Sorry. Here, no cycle is rejected, right? Position is at -1. Position we have considered -1. So quite obviously false, right? So let's move on with the final edge case here. Cycle at the middle node. Cycle at the middle node. So this one. So position we have been given 2 here in this case. Position we have been given 0, 1, 2, 3, 4. So this is the middle node right here. Position we have been given 2. So this one, node 3 loops back, forming a cycle. Node 3 loops back, forming a cycle. This one we have to consider. We can consider like this, right? So node 3 loops back, forming a cycle. You can just apply the hare and this one, tortoise and hare algorithm. You'll so here there will be collision and cycle will be detected, right? So in this case we have to return true, right? This is simple to understand. These are the 5 edge cases that we need to consider, right? So the first edge case is for this one, empty list. The second edge case is for single node, no cycle. The third edge case is for two nodes cycle exists, and the fourth edge case is for long list, no cycle, and the fifth edge case is for cycle at the middle nodes. These are the 5 edge cases that we need to keep in mind before writing the code. So now we are completely familiar with the approach as well as edge cases. As we are familiar with this one code, as we are familiar with the approach and edge cases, it will be easier to write the code. Let's start writing the code. So first step here is just give me a second here. So we have already discussed this one in the edge cases. So if empty or single node exists, then this one, no cycle, right? So we have already discussed this one multiple times. So I'll just go with simple if condition here. If head is null, we are comparing right here. Sorry, I'm not typing. If head equals null, this is fine. Or head dot next means if it consists of the head consists of the single node, then also no cycle exists, right? So that one head dot next equals null. Then what we will do, we have to return false in that case, right? If no cycle is detected, then we have to return false. They have that's what they have asked in the question. So we as we have discussed, we'll be going with the tortoise and hare algorithm. So we'll be making use of 2 pointers, slow and fast. So I'll just go with here list node slow here in this case. Slow equals head, and one more thing, fast equals head. This is fine. Fast equals head. This is fine. So the next step here is we have to make sure that the fast pointer doesn't go out of bounds, right? So we have to make sure that the fast pointer doesn't go out of bounds. So let's quickly write the while loop here. This one, while fast not equal to null. So this is Java, right? You shouldn't be making use of double equals here. Means not equal to single equals we have to make use of, right? So this is fine. Ampersand fast dot next here in this case. If it is not equal to null in this case, so we have to make sure that the first pointer doesn't go out of bounds. That is the reason I have written fast not equal to null and fast dot next not equal to null. It shouldn't be null at any cost, right? It shouldn't go out of bounds. So within the while loop, what we will do, we will move the slow pointer one step and we will move the fast pointer two steps. So I'll just articulate that one in the form of code in this way. Slow equals slow dot next one step and fast two steps, right? Fast equals fast dot next dot next. This is fine. Easy to understand, right? So if slow meets fast, then cycle exists. Means if slow equals fast, then the cycle exists. In that case, we have to return true, right? So we have discussed this one multiple times. Let me give you a return true. Else, what we need to do, if no cycle exists or if no cycle found, then we have to return false in that case, right? So I'll just give here return false. This is fine. So let me format the code once and let me hit the run button. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case. Let's see. Let me hit the submit button. Let's see whether this works for all the test cases or not. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So now, as the code works absolutely correct for all the test cases, let's quickly discuss the complexities for the code that we have written. So one thing we know, the approach that we went with here is this one, Floyd's cycle detection algorithm or tortoise and hare algorithm, right? So what will be the overall time complexity here? The overall time complexity would be big of n. Why it is big of n? Because in the worst case, both pointers traverse at most n nodes. We know this one, right? At the worst case, both pointers might or traverse at most n nodes, right? So this is fine. So overall time complexity would be big of n. Simple. The space complexity here is big of 1. Why it is big of 1 here? Because we are making use of only 2 pointers here, right? Slow and fast. So this consumes constant extra space. So we are not, constant extra space. We are not making use of extra space, right? So slow and fast pointers, we are making use of slow and fast pointers, which consumes basically constant extra space. So overall space complexity would be big of 1 in this case. So time complexity would be big of n, and the space complexity would be big of 1 for the code that we have written. I hope complexities are clear. I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.